Okay, so now we want to talk about graphing these type of functions. Please remember, you can always fall back on using your calculator to graph or making an XY table, but you should still kind of understand how the function works. Okay, a function in this form, y equals some a number times e to the rx. Remember that e actually represents a number, don't forget that. That's called a natural base exponential function. Okay, very good thing to put in those notes. Two different types. We studied exponential growth and exponential decay. If this format, if you have your number in front of e, your a value, and your number that's in your exponent, if those are both positive, then you have an exponential growth function. Okay, if a is still positive, but you have a negative exponent, that's an exponential decay function. Okay, and we're going to see some examples of that. Okay, so now we want to graph these functions. Remember, you can graph this in your calculator. For a, I'm going to look at two things. I'm going to say, is my a value, that number in front of e, is that positive? Oh, yep, it's positive. So since that's positive, now I'm going to look at my exponent. Is my exponent positive or negative? That's also positive. So that tells me I have an exponential growth function. And I know that that means my curve is going to go up. Okay? And that also gives me my quick, easy method to graph it. Remember, when I plot those points, something goes with a 0, and a number also goes with that 1. Okay, we did discuss that in class, and you should have it in previous notes. Whatever number is in front of e, your a value, okay, whatever we look at to see what kind of a function we have, that's going to go with your 0. So 3 is in front of e, that goes with 0. Okay, to figure out what point goes with 1, I'm just going to multiply 3 times e. Remember, e stands in the place of a number. On your calculator, you could type in e to the first power times 3. And that should give you what it equals. And it's 3.85. So I'm going to graph those 2 points. 0, 3, and 1, 3.85. Probably about there. And I'm just going to estimate the curve. And that's 110% fine. Okay, so we have our typical exponential growth curve. That means that the domain is going to be all real numbers, and my range, again, we have that asymptote at y equals 0, so my range has to be y is greater than 0. Okay? Okay, so now we're going to graph a exponential decay function. Okay, first thing we got to notice is our a value, our number in front of e, is positive, which is good, but our exponent is negative. Because of that, we have a decay function. And it might even help to think of graphing that simplified function just to get that curve first. Remember, you can just type this in your calculator and get points that way. That's probably the easiest thing. Okay, but our very first step is we want to graph the simplified function. We want to graph y equals e to the negative 0.75x. We want to graph that first because that's going to tell us the shape of the curve. Best way to do that is with your xy table. Okay, so once you pick your values for your xy table, I picked 0, always a good starting point, and negative 2. For an exponential decay function, you're going to want to pick negative values more than your positive x values. Because if you think about it, your curve starts higher.
Teachers, just a reminder, we will be meeting in the library for our PLC work today. So we will meet initially in the library in your PLC groups this afternoon. Thank you.
It starts higher up in your negative x values and kind of goes down as you get into the positives. So we picked 0, we plugged the 0 in for x. When you do that on your calculator, you're actually typing in e to the negative 0.75 times 1, which is just 0.75. And that gives you 1. Okay? For this next one, you're actually typing in e to the negative 0.75 times negative 2. And that gives you 4.48. We would then plot those 2 points and draw in that smooth curve. And then move on to step 2, which involves translating our shape of our curve. So now, once you've graphed the original curve of no translations, just the curve itself, ignoring negative 2 and 1, you then want to translate your curve. We see that we have x minus 2. You have a negative 2 with your x. And remember, anything with x tells you which way to move your graph, left or right. We have a minus 2. Remember, we got to pull the opposite out of there. So that actually tells us to go in the positive direction. We have a negative 2. We go positive, pull out the opposite, 2 spaces. And then I think at the end, we just do what it says. We want to go right 2, up 1. So we're going to take each point, move them right 2, up 1. Right 2, up 1. And we draw in that smooth curve. Don't forget that your asymptote moves with it. We had an asymptote, your typical asymptote for a decay function at y equals 0. But we now moved our function right 2, and that's not going to affect our asymptote because that's a line. It doesn't matter if you move it to the right 2. But it is going to move up 1. So we now have an asymptote at, oops, my smartboard is being a little choppy here. We now have an asymptote at y equals 1. So that would make our domain still all real numbers, but our range has to be bigger than 1.